Hello everyone. This evening we are featuring Dr. Berrie Tan with our webinar on Eannatto tocotrienol, the superior source of vitamin E. Just a quick reminder before we begin the presentation. The presentation will be approximately 45 minutes. My name is Upasna and I'm the director at Wellness Extract. To introduce Dr. Berrie here, as we begin this evening, Dr. Berrie Tan earned his doctorate in chemistry and he became the professor of chemistry and food science and nutrition in University of Massachusetts. His research expertise includes lipid-soluble nutrients, CoQ10, and omega-3s. He was the first to introduce tocotrienol benefits to the nutrition industry and developed the first tocopherol-free tocotrienol product derived from Eannatto. Today, his research focuses on lipid-soluble nutrients that impact chronic conditions. Dr. Tan is also the senior editor of Tocotrienol Vitamin E Beyond Tocopherols, published in 2013, and he continues to collaborate with numerous universities worldwide for further tocotrienol research. So now, I pass on to Dr. Berrie Tan.
Thank you for introducing me, and thank you for the audience who have signed on. So every time I've given this talk, and I've done this talk many times, it's always a tinge of excitement and a tinge of uncertainty, but I'm grateful that all of you could come, and I hope that as we go through the slide, and by the end of this slide, you'll be able to see that something have changed in the perspective and your understanding of vitamin E, because vitamin E as it is today, alpha tocopherol is a blah. And then as I go through, I'll be able to show some of this. I've been working with vitamin E, both tocopherol and tocotrienol, for the last 35 years. And you will see the progression and why it had been so much talk about tocopherol initially, and how it has slowly changed to tocotrienol, and why didn't we know about tocotrienol any earlier than now. So hopefully this will give a good perspective to you and how you may use this information and be able to take care of your patient under your care. So thank you for attending. So tocotrienol and the vitamin E beyond tocopherol. Like this, I came to Massachusetts in 1982 and never left, and I'm still a stone throw away from the university. For the objectives, I'm hoping to cover, as you see, the origin, the history, and quickly move through the different kinds of vitamin E for tocopherols and for tocotrienol, and then focus mainly on the functions and the benefits. It all began almost 100 years ago at the University of California at Berkeley, two pediatricians. They found a compound, and of all places in spinach, that it is a necessary factor, essential factor for reproduction. And you may or may not know that is what alpha tocopherol was first discovered for, not as an antioxidant per se, though it is. And so is tocotrienol, but it was first discovered and became a vitamin because of its essential factor in reproduction. So now you see a very quick snapshot on the top on tocopherol, 1922, and then almost a few years later, the actual structure was discovered, so some 12, 15 years later. And in the 1950s, because we processed a lot of soy oil from soybean, and then the byproduct is the tocopherols, mixed tocopherols, and then they convert them to alpha tocopherol. And I know it's a small point, and when we say natural alpha tocopherol, it is not entirely natural, because when you get them from soybean, they're mixed tocopherols, mostly gamma tocopherol, and they convert everything to alpha tocopherol, and that's your natural alpha tocopherol. The tocotrienol came about 50 years later. It is a very American affair. It was discovered in the 1960s. They extracted this from rubber, and then some connection to England, because University of Bristol as well as the USDA unraveled this molecule in 50 years later. Is very similar to tocopherol, like that. And then in fact initially it was mislabeled, Greek letters like nu, epsilon, and zeta tocopherol. they were actually tocotrienol, but they did not correct that until 2001 in the Merck index. So you can see, so by its own accord, it was never going to be known any sooner to the public. I came to the university to study in 1982, and then I discovered this from Palm, 1992, and then I did it from Rice some years later, and then the most recent one is Eannatto. So here, this is the only picture of natto you see. We use Eannatto for coloring like this. So if you look at the fruit, the part that is open, you don't see a flesh. You just see the seeds, and then there's a color. If you touch the color will stain your hand, and hence the British call it the lipstick plant. We normally call it Eannatto because of Eannatto coloring in cheeses, in meat. How did I discover this compound? So for me, this is very passionate to me. Yes, I'm a chemist. Yes, I'm a biochemist. I learned all these different things, but this discovery is a guided thing, guided from my science as well. I happened to be in the right place when I went to South America like that. When you think of carotenoids in nature, that color bixin you see from the Eannatto is a carotenoid. Most of us know omega-3 is very unstable. Let me give you some very quick understanding, and then you can appreciate how unstable carotenoid is vis-a-vis even omega-3. And then from it, why did I figure out that this might be tocotrienol? And omega-3 would be C20, 20 carbon to 22 carbon. And they typically contain 5 or 6 double bond. That's considered very unstable because we say omega-3 is very unstable. Well, now let's take it in perspective. A carotenoid is about C30 or C40, a few more carbon. Number of double bonds in the carotene, 10 and 11. 10 and 11 double bond compared to omega-3, 5 or 6. That means the double bond is going to be massively unstable. So when I saw this plant and saw that the bixin is on the seed and there's no flesh, nothing to protect it, I surmised something very potent must be protecting this highly unconjugated double bond keratin, as all keratins are, lycopene, beta carotene, zeaxanthin, the whole carotenoid family like that. But most of them are bound to something, like the fall foliage color because it's masked by chlorophyll, like that, or in lobster it's bound to protein, or a beta carotene is bound to the cytoplasm. But in this Eannatto, it's not bound. So I intuitively thought that there must be a very potent antioxidant that would protect it. I was thinking that it would be a polyphenol, something like that. And then, but when I looked at it, then I was amazed. This one showed it. First, in the center of the picture is vitamin E. On the left side is 4 tocopherol, the 4 Greek letters, and on the right side is 4 tocotrienol. If you run the HPLC of Eannatto, you have no tocopherol. You see, if you see the retention time 2 to 4 minutes, that would be where tocopherol peaks would show up. Never see it. And then when you see on further about a little bit more than 6 minutes, a little bit more than 10 minutes, that is the smaller peak is gamma tocotrienol, like the indication show, and the 10-minute is delta tocotrienol. That's it. Every time when we look, the HPLC chromatogram is almost boring like this. But this boring is exceedingly passionate to me. Of all the 8 isomers of vitamin E, tocotrienol has definitive great function. Tocopherols never come to the forefront. At the very most, they are antioxidant. That's it. And of all the tocotrienol studied, the one that is most potent is delta tocotrienol. This has nothing to do with Eannatto. It just is. When scientists do this, is all the time is delta tocotrienol most active, followed by a close second gamma tocotrienol. And now you look at HPLC, it's 90% delta and 10% gamma. It's as good as you're ever going to get. Now on the top right and top left, you can see the structure. If you look at tocopherol and tocotrienol, the ring structure look the same. And you look at the tail, it's just a 3 double bond on the tocotrienol. So tocotrienol is an unsaturated vitamin E. That's it. Other than that, they're analogous. Now, I'm going to come to visit this structure here, this phenolic ring here, and over the same with tocopherol here later when I talk about the estrogen in women. But just remember that structure. We'll come back to it. Now, in the body, you have in diet. If you eat diet, you will have maybe 5-10% tocotrienol at most. Most of it in the diet is gamma tocopherol. But if you take a supplement, typical supplement for vitamin E, it's very similar to the diet one, except that the supplement don't even have any tocotrienol like that. However, when you take the supplement, whether it's a mixed tocopherol like this, or worse, if you just take 400 IU or 400 milligram alpha tocopherol, notice how I said it is worse. When you take it in the body, it will look like this. So regardless of what tocopherol you take, your blood vitamin E always look like this. So now that raises a question, why is it that when I take all the tocopherol, I always mostly get alpha tocopherol like this? The reason is because we have a protein in our body called alpha tocopherol transport protein. It conserves all the alpha tocopherol and excrete all the other tocopherol out. So if you take tocotrienol with alpha tocopherol, it will conserve alpha tocopherol and excrete all other tocotrienol out. So intuitively speaking, if tocotrienol have the best function, the last thing I want to take the tocotrienol with is with alpha tocopherol because the body simply conserves it, as you can see from the blood here. Now, before I get into the blood work thing, let me touch on one or two things, and these are two extreme examples of tocotrienol as an antioxidant. On the left side, on the right side here, you can see we have put it in omega-3 soft gel at 25-30 degrees, kind of like room temperature, and the peroxide value would drop, which is what you want as a measurement for good omega-3. Now, at 6.5 times higher temperature, 160 to 190, this is frying oil. This is done by USDA. They deep fry tortilla chip. When they do this is extreme. It's not a human body thing. And if you read on the bottom here, pretty much you can read faster than I can tell you this. Is able to stabilize, to reduce polymerization of the frying oil, which is what you want if you're in the food science of this. And it incorporates into the chip and it helps the stability and to preserve the flavor of the tortilla chip because that's what USDA did like this. So all this to say, whether close to room temperature or frying temperature, tocotrienol clearly is an antioxidant. But the kind of antioxidant that you and I care about is in the human body. Let me take a moment to explain this. If you think of a human body, it is about 10,000 times the population of the Earth. So I need a little bit of clarification. We have approximately 7.5 billion people on the Earth. And about 10,000 times will be 75 trillion cells in one human body. And each cell is wrapped around by the biomembrane like you see here. Tail to tail, this would be exemplification of the fatty acid, and this would be the phosphate group here. And together they form the biomembrane. Now, omega-3 is popular today. So if you take more omega-3, the omega-3 will be part of the phospholipid here. The omega-3 can't be floating triglyceride in the blood forever. Eventually, it incorporates into the cell wall. So I'm trying to explain the justification why a normal human being needs 150 milligrams of tocotrienol. That is to protect all the 75 trillion biomembranes here. And about 25-30 years ago, University of Austria, Professor Hermann, he did a study. This kind of biochemists don't exist today anymore. He took all the cell wall biomembrane and he extract all the antioxidant out, the one that protect the lipid here. And he found that 95% of all the antioxidant to protect the lipid, they are vitamin E molecule. Now, I'm trying to cut the noise out. Everything out there, people say that they're antioxidant. I encourage you not to believe them. True, CoQ10 is an antioxidant. True, astaxanthin is a super powerful. Sometimes they say 100 times, 1,000 times like that. So these things are thrown out there and it's hard for us to grasp. So we need to understand the contextualization of this. Yes, the protein need to be protected. The nucleus need to be protected from oxidation. However, I will make the assertion. I want the thing to be protected to be the one that is easiest to get oxidized because it will be the first to go. And what would be the first to get oxidized in your body? It is the 20 to 25% of your fat. When you smell a roadkill, the first thing you smell of is the fat gone bad. It is not the protein gone bad, and it's definitely not the nucleus inside the cell gone bad. I can assure you, it's a fat gone bad. So therefore, when you ask me what antioxidant I'm looking for, I'm always say, is it a lipid antioxidant? If it isn't, I'll deal with the lipid antioxidant first. And if you do the math, and then you calculate about 500 parts per million to contain all the cell wall, to do the math, you'll come up to approximate to 150 milligram. So very simplistically, I would say 150 milligram tocotrienol would be our daily consumption. Here I had a picture of tocopherol and tocotrienol. The head of a tocopherol tend to be bigger and the tail is long. Typically, the molecular weight of a tocopherol exceeds 400 and the molecular weight of a tocotrienol is 400. So I use the analogy of a policeman, which is a tocopherol, and the state trooper for tocotrienol. The tocopherol protect antioxidant in a more localized area, like a policeman in a town. And then a tocotrienol will be able to crisscross the entire state. Even though I gave that as a metaphor, Professor Lester Packer proved this, UC Berkeley professor, and he published about this in 1997, and 1995 and 97. So that part tells you about the antioxidants. So now I'm going to move on. People want to know if you use tocotrienol, is it safe? So I put this slide up. So it is what the slide says. I'm going to say that tocotrienol is inherently safe. Research. Most of the research in the first 50, 60 years were on tocopherol. And then 50% in the last 30 years, 50% of all the research that have ever been done on tocotrienol, which happened in the last 30 years, actually happened in the last 5 years, or at most, if you stretch it, in the last 10 years. Let me repeat. Half of all the research on tocotrienol ever published was published in the last 10 years. So if you asked me earlier, yes, I started tocotrienol research 30 years ago. I know a lot less, if you would ask me, than it would be today. And most of those are on chronic condition, like you see here. Meanwhile, for tocopherol, it's still languishing on just being an antioxidant. And there are also emerging ones, and I'll try to cover some of this as well. Natural abundance. There are many tocopherol found in plants, but when it comes to tocotrienol, there are three. And all the three, I discovered it, if I may say so myself, in the last 20 years. First, I discovered it from palm. It contained 25, the teal color contained 25% tocopherol. Later, I discovered it from the rice bran, about half of it at tocopherol. I was disappointed. I can't change what the plant does. I was disappointed because it's got too much tocopherol, and tocopherol is a bothersome because it interferes with the function of tocotrienol. I'll come to that. Then, about 20 years ago, I found this, and I told you the story how I discovered this. I was stunned. So when I found that there is a plant They completely make tocotrienol and there's no tocopherol. I think I got it. So I went immediately called the father of modern day tocotrienol function, Dr. Karashi. He was in University of Wisconsin then. I remember distinctively he told me, he said, Barry, if tocotrienol will mitigate diseases, your Eannatto tocotrienol better do. And he was the first to conduct my earliest clinical study because I got this 100% tocotrienol. He was not going to do any more study on these two because the tocopherol put brakes on the function of the tocotrienol. By the way, this is the only slide that I'll come back to at the end. So now, why tocopherol free? Tocopherol interferes with the function of tocotrienol. You can read this. If tocotrienol, I want it to absorb, if it's going to be deposited in the adipose tissue, lower cholesterol and triglyceride for people who prevent arteriosclerosis, prevent metabolic syndrome, they have high triglyceride. I want it to do that. I don't want it to be compromised. I want it to kill cancer, apoptosis, and anti-angiogenesis, and all these wonderful things. I do not want it to be interfered, but tocopherol would interfere. Be glad to send you any of these papers that show that. Now, tocopherol by itself also have physiologic function. You can just read. When the tocopherol is too high, it actually does not protect the LDL. It oxidizes the LDL. How about you take the position you don't trust me? I will be glad to send you those papers. And when you read, and this is published in the American Heart Association paper. Why are we not hearing about this? I don't know. And then high amount of tocopherol actually increase cholesterol synthesis, increase high blood pressure in adolescents. And this one is probably on the news a lot. So you hear about increasing some cancer thing like that. So tocopherol is a lipid antioxidant and nothing more. I cannot think of anything more that it does to intervene condition. So let me touch on a few on how alpha tocopherol interfere or stumble the function of tocotrienol. This is the one. This is classic. This has nothing to do with Eannatto. This is from palm, tocotrienol rich fraction. It contains about 25% tocopherol. Just imagine if you have a process like chromatography, you cut this cake off, cut the alpha tocopherol off, and then it's going to look like this. So this is tocopherol-free palm tocotrienol. Somebody actually bothered to do this experiment. So you have 32% alpha tocopherol and 0.3%. And they give this to people. And here's the result. You can see the alpha tocopherol, the hollow bar with alpha tocopherol, the alpha tocotrienol, the gamma tocotrienol, and the delta tocotrienol drop. And the delta and gamma tocotrienol is the most potent. It drops 6 to 7 times. So if the presence of alpha tocopherol is going to cause this, well, I want the alpha tocopherol to be out of it if you want the function of the tocotrienol. And this is a clinical trial just to prove that alpha tocopherol mess it up. Here is an alpha tocopherol. You see here, 33% alpha tocopherol, less than 10 and 0. As you have higher alpha tocopherol, you need a high dosage. When you have 0 alpha tocopherol, you need much less to see action of LDL dropping, triglyceride dropping, and even shorter time to see result. These are earlier studies. This is done in Ohio State University. This is very serious condition, stroke injury. They even did a study here. You can read the conclusion here. The wild type, meaning that these are just normal animals. They would have the alpha tocopherol transport protein, and therefore they conserve the alpha tocopherol. This is hybrid type. Let's knock out mice, meaning that they genetically manipulated a mouse that have no alpha tocopherol transport protein. Can you imagine that? They went to the nth degree to do this. So when they have to knock out mice, that means that they don't recognize alpha tocopherol. It will, all the tocopherol, tocotrienol go in, it's just by passive diffusion. The more you put in, the more it goes in. The less you put in, the less it goes in. And there's no preferential thing for alpha tocopherol because they knock out the mice capability to do this. And when they did, you notice that the percent lesion drop. That means that in the wild type, when they conserve and grab the alpha tocopherol, it prevents the lesion from healing by the tocotrienol. Can you imagine this? This is as good as it's ever going to get. They prove it by genetically figuring out the mouth. And when they do, then the lesion drop. If not, they'll conserve the alpha tocopherol and the tocotrienol is not able to prevent stroke. I think that study is elegant. This one is cancer study. This Japanese group figure out that they try all the tocotrienol and tocopherol and they found the delta tocotrienol worked the best. So in this colon cancer, you see, this is zero control. They put exactly the same amount of delta tocotrienol here. And then they start adding alpha tocopherol more. As they add more and more alpha tocopherol, the amount of delta tocotrienol begin not to be absorbed. So then the uptake of tocotrienol is inhibited by alpha tocopherol. Here, apoptosis, these are cancer. The cancer kill is compromised so that as they increase the alpha tocopherol, they successfully, if I may use it ironically, the delta tocotrienol simply did not even kill the cancer cell. And all this by adding in alpha tocopherol. So it compromised them. So now enough of that. We'll give you some clinical study on tocotrienol, what it can do. Dr. Qureshi, the father of tocotrienol function, did this study. When he did this study, he had 125, 250, 575 milligrams. And then sometimes people say more is better. We did not find more is better. At 250 milligrams, it lowered cholesterol 15%, LDL 18, and triglyceride this amount, like that. And then at 500 milligrams, it's still lower, but not as much as 250. So when he did this experiment, I asked him, can you please measure inflammation as well? Because half of the people who died of heart diseases have normal cholesterol, but they have high inflammation. And thankfully he did. So the next slide is the same design of the study, but he did that. So you notice this, the total antioxidant is the only one that got. This is endogenous antioxidant increase. And then at 250, you see the C-reactive protein drop, the oxidized fat drop, and the total antioxidant would increase. So I'm really thrilled to see this. So interestingly enough, as far as inflammation is concerned, the 500 milligram continue to work as well. So therefore, for people who don't have cholesterol issues but would like to have the inflammation control, 500 milligram work just as well as 200. But if you want to map both the cholesterol as well as the inflammation, then the 250 would work just fine. We also study arteriosclerosis. Clearly, we cannot study in human beings because you cannot see this, but because you cannot cut people's artery to see this. So we did an animal study on this. So if you see this, alpha tocopherol, no change. And then with delta tocotrienol, 25% regression of the arteriosclerotic lesion. And then with the whole artery on the vena cava, the descending artery in the heart, you can also see that the delta tocotrienol reduced. This was a Japanese study. This is a Malaysian study. When you have the earliest stage of a plaque forming would be things that would stick onto the artery. When things flow in the artery, you want it not to stick on. So I created this phrase, VELCRO effect. Scientists like to call chemotaxis. In other words, a chemical that is toxic is taxiing on your artery. You don't want chemotaxis. So you do not want VELCRO effect. So this group study the inflammation marker. It dropped on longer period. It also dropped on earlier period. Here they have adhesion molecules. Interestingly, it captures your image. Adhesion molecule are simply adhesion molecule. They are vascular, cellular, adhesion molecule, intracellular adhesion molecule 1. They are protein material. They kind of like cling on, and when they do, then they'll bring in macrophages, and then the macrophages take the cholesterol onto the endothelium, and then they form a small plaque, foam cell, stuff like that. We hear many of these being described. So you don't want adhesion molecule to cling on. You notice that it inhibits the adhesion molecule. Proteolytic enzyme also drop. What is it? You hear a doctor say that once you have the plaque, all right, it's stuck there. So now you want your plaque to be stable, because unstable plaque will rupture and will recruit platelet, not a good thing. So if you already have a plaque, you do not want the plaque to rupture. And what causes plaque rupture? Proteolytic enzyme. Proteolytic enzyme just mean digestion enzyme. So, and where do they chew up? It's usually on the fornices, the both ends of the plaque. And when they chew them up, that's when they have a lesion, and then the platelet would come. So you see, it inhibits inflammation, adhesion molecule, and proteolytic enzyme all added together. Tocotrienol reduce the VELCRO effect on the artery. I'm going to move on to fatty liver. People who have fatty liver have cardiovascular disease, but I'm specifically talking about fatty liver and how this travels. They are associated with obesity and metabolic syndrome. Is the 21st century epidemic in the liver disease, and 1/3 of American adults have this, and it would transition to alcohol steatosis, NASH, like here. When I was looking into this, I was initially not impressed, and then I was stunned. You know, the liver is surprisingly very intolerant to fat, like something like more than 5% fat. That would be already fatty liver. This is a problem. And so for people who have obesity, metabolic syndrome, is only in this stage here. So when they get further, this is not a good sign. This is the clinical trials we did. So the answer is simply on the left side. So if you just take a moment to see, this is quite dramatic to me, because we're talking about a nutritional supplement. It lower triglyceride, which is very important, and it lower enzymes in the liver, which is important. And so is C-reactive protein and oxidized fat. And in the end, the fatty liver index also dropped. Okay, so this one here is a 300 milligram twice a day. In the earlier study, 250 or 300 milligram, and in the very first one, I mentioned that for a normal person, 150 milligram. So that would be it. So then for the round number would be 150 milligram for a normal person, and 300 milligram for conditions such as this one here. They use twice a day. I'm going to move on to another liver condition, hepatitis C. This one surprised me somewhat, although this is a condition that is increasingly more prevalent in our country. When a person has hepatitis C, they have a higher incidence of chronic condition, liver scarring, and other things that you can read here. When we did this a pilot study. We only had 12 patients with hepatitis C, and they only taking 500 milligram per day for a month and a half. So all the things that delta tocotrienol downregulate and upregulate. You probably can read this faster than I could. So I'm just going to go to the bottom here to show you that delta tocotrienol decreases the viral load. This is music to anybody's ear, because this is Hep C, it's a virus. And if it reduces viral load, that is welcome. It also reduces the infection and the progression. Infection, because people have this virus, have compromised liver, therefore things like this thing here. You see, they're going to have infection of this kind of condition. This is just a fancy way to see it. So in terms of the hot spot like this, they downregulate the infecting. The cold spot here, they are normal tissue they didn't. So the data is way too much. So I just gave you a picture to know the place you want it, the hot spot area, you want it to downregulate. The cold spot area, you want it to upregulate. This is exactly what the delta tocotrienol can do. I know I'm rushing through this slide a bit, but I just want the audience to, we are talking about a nutritional supplement that happens to be a vitamin E molecule. There happens to be an unappreciated vitamin molecule. And I've spent my last 30 years to do all the cell line study, to do all the animal study. And now I'm putting everything that I got and show you clinical trials. This is as good as it's ever going to get. And the delta tocotrienol is from an Eannatto plant that almost contains all delta tocotrienol. If you ever were to come to visit me, I will probably show you how we did. We do not use chemicals and we do not use solvent. We just use a physical process to do it. You'll be proud to take this. And we make it here in the United States of America in Massachusetts. So sorry, that was a little thing that just come to my mind I spoke about. I'll move on. Cancer. This is a biggie for us. Lung cancer leads the pack. And then if you combine men and women on the sex organ cancer, breast and prostate, and then next to it is colorectal cancer and pancreatic cancer, liver, and then just below here, I did not print out everything that I got from American Cancer Society, then it would be liver cancer. Oh, you can see from here, see, lung first, and then hormonal breast and prostate, and sedentary lifestyle, colon and rectum. And if you combine pancreas and liver, I did this intentionally. I believe that pancreatic and liver cancer is dietary origin. It's high fat, high carb diet, high bad fat and high carb diet, purified carbohydrate that cause it. And then all the other combined is less than 50%. And these two had slowly creep up. It was in the 7th or 10th position before, and it got to this position now. And the lung and these two cancer is probably going to be the top regardless what we do, and this because of sedentary lifestyle. So what you see is what it is. So we took the big cancer to see what tocotrienol can do on them. Delta tocotrienol inhibits cancer angiogenesis. So there are too many studies on this, but if you look at this, you see it brings about apoptosis, it nails down the cancer, and is able to have anti-angiogenic effect. This group study all the different kind of tocopherol and tocotrienol and delta tocotrienol stack up on top. And you can see the one with delta tocotrienol, besides that the tumor is a little bit smaller, you can also see that it's anemic looking. It's anemic because it's anti-angiogenic. It doesn't build in blood vessel, and therefore the hemoglobin didn't go there. That's pretty much that's what it is. And delta and gamma tocotrienol is superior in breast cancer. There's a many studies done on this, and so we decided to do a randomized clinical trial in the last 2 years on this. The results will be forthcoming in the first and second quarter of 2019. So wait and see, it'll come soon enough. Look at this. In animal study, delta and Eannatto tocotrienol is most potent in reducing in HER2, one of the most severe breast cancer that is. And then we also did a study in mice on this too. I usually do not put molecular biology on the screen, but I want to put this. This is almost elegant to perfect. This thing here is the ribbon representation of the estrogen. And this is a stick representation. This green thing is typically what you expect if the estradiol is there. Otherwise, it will look like the tamoxifen if you have breast cancer. However, this green is not that. It is delta tocotrienol. My friend, this is delta tocotrienol. It's published by the French. I had nothing to do with it. When they put the delta tocotrienol, it intercalates into it almost a near perfect fit. You cannot make, in other words, the one here are the hydroxyl group, and 2 is a phenyl group, and 3 is a farnesyl. Only tocotrienol have a farnesyl background, like here, number 4 here. So it has a perfect fit, and this whole stick thing here, that is the estrogen receptor. You cannot finagle the bagel. It either fit or it doesn't fit. And so when it could, so I am satisfied enough in my own assertion that delta tocotrienol would ward away breast cancer. prostate cancer. Prostate cancer here, androgen dependent and androgen independent. Most people is good enough for the take-home message that the PSA dropped 40%. But I want to go further. Sometimes they have refractory prostate cancer that dropping the DNA at PSA doesn't work, but the delta tocotrienol also go after the androgen independent. So I consider this a 1-2 punch. I want to do this quickly so I can present some clinical study. I gave tocotrienol to a University of Southern Florida professor, and he did it on pancreatic cancer. He initially did it on colorectal cancer, but it worked so well, he decided to graduate it to pancreatic cancer, which is the deadliest of all cancer. Notice when he did animal study on this, he came to this conclusion. I have nothing to do with it. He came to this, just read the last three things here. Delta and gamma tocotrienol work the best. It should be free of the other tocotrienol, completely free of alpha tocopherol. That to me is Eannatto tocotrienol. I don't know what else it is. He did not do this for me. He did this because he published this work here. If you ask me, I send you this paper, he came up with this conclusion like that. I want to go and tell you what he did. He got a National Cancer Institute grant, so he studied delta tocotrienol 200 milligram dose escalation all the way to above 3,000 milligrams, and he did not find any toxicity. His primary endpoint in this study was this: he giving it to people just before he give them the resection to remove the tumor. It was safe until 3,000 milligrams. The secondary endpoint was a cancer apoptosis. He noticed cancer apoptosis even as low as 200 milligrams. And he found that the tertiary effectiveness is about 5 times lower than the 3,000 highest dose. The 600 milligram is where he thinks the active dose would be. He used this one, exocrine cancer, which is 95% occurrence, the most lethal one. And this is his clinical trial. He published this. And remember, even as low as 200 milligram, it would kill the cancer. He found that the active range is somewhere between 400 and 800 milligram. So when he did the animal study, 600 milligram, he's asking the National Cancer Institute for a 2-center study. If he succeeds, I'll be anxious to know what dose he's going to use. My feeling is he's going to use 600 milligram for his dosage study. These are the actual sections of the people with cancer that he did. One at 200 milligram, the other one at 400 milligram. Actual dose to the patient whose tumor he excised and he saw the apoptosis. He went back to animal study. The only drug for pancreatic cancer is this drug here, very toxic, gemcitabine. Here, gemcitabine. When he add combination to gemcitabine at 4 months, 90% of the animals survive. At 5 months, surprisingly, 20% survive. And then if it's just gemcitabine, at 4 months, 30% survive. And then at 5 months, all of them die. So the fact that all of them die in 5 months, gemcitabine is terribly toxic. It kills the animal while it's killing the cancer. And even with combination, he only have 20% survive. Then look at it carefully. If you just give delta tocotrienol, 70% survive. Then at not as good as a combo, but at 5 months, 40% survive. That means that at 5 months, you're better off with more just delta tocotrienol than the combo. That just underscores that the gemcitabine is terribly toxic. Even the combination cannot reduce the toxicity of gemcitabine. That is his finding. He published this 2 years ago. So now cancer stem cell. We do not have clinical study or animal study on this, but I tell you what is coming. This is literally in the last 5 years, and the two of them is only last 2 years. Cancer stem cell. After you nail the cancer, hopefully we keep our fingers crossed it does, about 1% of the cancer still circulate. These are the road cells. They are not killed by chemo drugs. They circulate around. Would you believe this? There are 6 published studies. The delta and gamma tocotrienol specifically target cancer stem cell. I'm a happy guy. I hope you're a happy guy and share this good news to other people. We're glad to share you this. I'm hopefully that somebody would do this and show animal study, and perhaps this they'll take. In other words, if a cancer patient is cured of cancer patient, remember the cancer stem cells still circulate. So they want to continue to take it so that it will never come back again. So when people have relapses, it's not just metastasis. The relapses may be due to the circulating cancer stem cell. My last portion of here has to do with this, so I can get some time for it. So I'm hopeful to cover some of this. I'll go through this rapidly. You'll get the gist, I'm sure, and hopefully I can. We did some cataract study. This is a kind of an antioxidant work we drop it on the eye tab. I don't have a finished product, but I was thrilled that this professor did this study. And in short, just this part here. If most of the control group have this and then have stage 3, which means they score like the opacity you can see, and some of them even have stage 4. But on the tocotrienol, only a few have stage 4. Most of the tocotrienol have stage 2 because this is a gradation thing. As you go through, more of this happen. All this to say, if they don't have tocotrienol in an eye drop, they will quickly go to this stage where the opacity is. This is experimental Angiogenesis. But if they have the eye drop, it would be resisting it to have a cataract forming. So that's it. That's all I wanted to say on this. This is clearly an oxidative damage due to the exposure to the outside UV light as we age. I want to go to the radiation protection. A cancer patient have to go to radiation. This is performed by the Armed Forces Radiobiology and Radiation Institute. They're looking for compound that would protect our armed forces from radiation exposure when they go into harm's way like that. Like what you can expect today in Iran, in Pakistan, and in North Korea. That kind of thing. So when they irradiate the animal, you see, they have the white blood cell and the red blood cell must be back to normal in about 1 month in the yellow region. So when they gave them delta tocotrienol, the white blood cell, the neutrophil, the platelet, and the lymphocyte all was able to get in. So life as is sustainable is able to enter sustainability. If after 30 days they don't get back here, then life is not sustainable because you cannot give them perennial infusion of blood like that. So they did that. They also did survival. You see on control, after 50% survival, after 15 days, 15% survival. And then at about 18 days, all of the animal in the vehicle group died. And then delta tocotrienol, gamma tocotrienol, most survived. And at 300 milligram per kilogram, all of them survived. This one, I don't know how to translate the dose because this is given intramuscularly to the soldiers if they were to take it because it directly would go to harm's way. My take-home message here would be that this would protect a cancer patient if they were to go to radiation. And these are all the populous area in the United States that are nuclear plant. And where I live is in Massachusetts. If any one of the nuclear plant would be like Fukushima, I am toast. So now onto the neuron side. You can see here, this is a myelin sheath with DHA wraps around, and you can tangle up here. And this is the beta amyloid plaque if you have a dementia like that. So they have done this study, and tocotrienol is able to remove the tangle on here when you add in gamma tocotrienol like this. And this is the largest study where they can see that people with Alzheimer's disease is more associated with less vitamin E, and they notice that they're more oxidized vitamin E when they're disordered. So this is intuitive because it's not a clinical trial that is interventional, but it's a prospective trial. But we are at animal study now to look at the beta amyloid plaque in animal. It reduced 10%, and the ARC protein that helped to reduce the beta amyloid plaque increased 15%, and also the receptor increased 20%. We're not quite ready for prime time on this for a clinical trial, so I'm waiting to see. This study is done in Boston University and Georgia Tech. So for now, I can say that tocotrienol is a compelling insurance to cognitive acuity. I can't say more than this for now. So bone health, you can see all this thing here, been studied on animal. So, and this is on experimental CAT scan. You see on tocotrienol like the sham group, and if estrogen, similar, but a little less bone here, but uncontrolled, that means that if they over-retectomize the animal, then there will be estrogen diminishing, then you can see the bone, they don't have mineral. So this is animal study, pretty elegant, like that is done in Malaysia by an endocrinologist. You see here, the last two here have tocotrienol, and the bone structure looks similar to the control group here. And you can see it's denser, and the calcium is also contained, even under stress. And they fracture the bone, and they notice that the tocotrienol is able to help in the healing of the bone. All animal study. And the same thing here, you see, this is with tocotrienol more, and this also tocotrienol is similar to this. Compared to control high fat, high carb diet, you can see the bone thin here. And we wanted to do a clinical trial. Before we did this, this is what we did. Where postmenopausal women estrogen would drop, the oxidative stress increase, and I surmised that I was quite surprised when I did it. I purposely and deliberately superimposed an estrogen over a tocotrienol structure. Do you know that among the hormones we have, estradiol is the only hormone that is an antioxidant? You see the phenolic ring and OH group. You can trust me, you can go look. If you look at the structure of steroid, none of them have a phenol group like this. Only tocotrienol and estradiol have. So I was very excited about this. And okay, so this study on the human thing we had here is done in Texas. We gave women postmenopausal 300 milligram placebo. This is a double-blind placebo-controlled study. Placebo, 300 milligram and 600 milligram. So the shorthand is bone building up this amount, bone resorption down this amount. Remember, during this stage of her life, her estrogen dropped. You wanted to increase bone building and resist bone resorption, which tends to be so. I surmise strongly because the estrogen dropped, her oxidative stress increased. Therefore, we study an oxidative marker, and it is about 30 to 50%. So the placebo group, it continued to go up 6 weeks and 12 weeks, and in the low dose and the high dose. And surprisingly to us, whether it's low, the high dose did not perform much better than the low dose. So my conclusion is, to resist osteopenia, the 300 milligram work just as well as the 600 milligram per day. This is, I'm coming to the end now. This is my slide that I presented before. So all this to say, Eannatto tocotrienol have the two most potent tocotrienol without completely free of tocopherol. If you were to give it to your patient, please look carefully to see if they are not from palm, because they'll contain 25% tocopherol, and definitively not from rice because they have half of it. It would not serve them well for the benefit from tocotrienol. So this is a take-home message. You probably can read faster than I could read. So pretty much I covered this. So now the best practice application would be, as I indicated from here. And I want to go straight to the caution thing. If somebody is convinced still to take alpha tocopherol, I strongly recommend that you take the alpha tocopherol 5 hours apart. I personally quit taking alpha tocopherol a long time ago from the fruit and the vegetable that I eat, and vegetable oil is good enough. So now for dosage, tocotrienol, they're lipid soluble. They do not need anything to make it more bioavailable. Just take it with a meal. Antioxidant, I mentioned 150 milligram. Mild support, 200 to 400, so 300 will be right in the middle. Advanced support, then it will be 5 to 600 milligram. I would say for a normal person, because of the antioxidant protection I mentioned at the beginning, 150 milligram per day minimum, that would be good enough. And daily, yes. I believe that question come from some physicians said that antioxidant is not good because they seem to foul up the capability of the chemo drug to act. Probably that is that fear. I have asked this question. Surprisingly, European physicians do not have this problem. We are conducting 5 clinical trials on cancer in Europe. And if they are taking chemo, they continue to take chemo. If they're taking radiation, they continue. They're taking 900 milligram on stage 4 cancer trial. Most of them have gone to 1 to 2 years and they have no problem taking tocotrienol in conjunction with other standard of care. So there's no problem that I know of. Based on the study that we have conducted, we feel that up to a maximum dose of 300 milligram at one shot, at one sitting is best, not more than that. Meaning that if you have to take 600 milligram, you do it BID twice a day. Maximum of 300. We actually have some study on that was published by Dr. Qureshi that much above 250 milligram, then it should be a divided dose. Below, so if you round it off, below 300 milligram, a single time would be fine. Even if it's none of those conditions, I would recommend people to take 150 milligram just as an antioxidant protection. However, if we have a family history of this disease or that disease, like some of the conditions that I mentioned there. However, the person who's planning to take it does not have it, so therefore it's a preventive situation, such as if I were to be a woman, 50 years old, after menopause, then I would consider doing this because it is osteopenic for 10, 15, 20 years, and then osteoporosis come after. So as the prevention thing, yes, I would do this. We have done many animal study to show that prevention matters, and tocotrienol can help like that. Among the tocopherol, I would say gamma tocopherol and delta tocopherol have some value. And so some mixed tocopherol are used at gamma and delta tocopherol. Gamma is more well known because about 30 years ago, somebody did some study on nitric oxide prevention on those like that. So if you take gamma tocopherol, to the best of my knowledge, gamma tocopherol does not directly interfere with tocotrienol function. That would be fine. The one that is documented repeatedly is alpha tocopherol, the most common vitamin E, that would interfere with tocotrienol. So I would be fine with gamma tocopherol taking that. It won't intervene, it won't trouble tocotrienol functions. We had worked with a group called familial dysautonomia. You can go to the website. It's a not-for-profit organization, fdhope.org. They have used it on young children because they have this devastating genetic disorder, and they typically gets 5 to 600 milligram of the tocotrienol, and they've been taking it for years, and they have no problem with familial dysautonomia to young people. It doesn't have to be less than 10 years old, all the way up to 20, 25 years old like that. So they have no known reason, no bleeding problem when they have to go to operation or any other thing that I am aware of when they take the tocotrienol. And typically they take 5 to 600 milligrams. I'm probably the only one standing that have taken tocotrienol longer than anybody else, and I have men pattern baldness. So I wish this would be true. I did see some animal study on this, but I did not see. I think the androgenic response of a human body would overwhelm the ability for hair growth. The idea for hair growth in animal study first came out from newt mice. They were doing animal study on this nude mice. It's a genetic mice, and then they noticed that the hair start growing on their body. Now that is not androgenic. It was a specifically genetically modified mouse to have no hair on them like that. So that mechanism might be different. However, if it works, I'll be glad. I've seen some paper published on this, but I have not seen it working on me. I'll be the first to tell you if it does. So this vitamin E is so unusual and so special that we have our ongoing study. So the audience should be waiting and see for the next year or two. We have ongoing clinical trials in cancer. And the cancer that we are studying are ovarian cancer, breast cancer, colon cancer, and lung cancer. These are clinical trials. We are studying diabetes and metabolic syndrome with diabetes, another one. We are also studying in Texas obesity and how tocotrienol help in these obese women who simultaneously are also masked by sarcopenia. And lastly, we are also studying the aging skin, actinic keratosis, and acne. So even if you were not to believe me, I hope you do, even if you were not, imagine this. I put every resources that I could against doing clinical trial to prove to you. I'm confident. So far, every clinical trial we have studied, first we did a lot of them for animal study, and every clinical trial we have committed on it, it worked. The first of the cancer study should be out in the first or second quarter of next year. I'm not at liberty to tell you the result, but I will be thrilled when the result come out. That's all I can say for now. Today we have an exciting news of something I discovered 20 years ago on Eannatto tocotrienol containing only delta tocotrienol and gamma tocotrienol from the Amazonia without any tocopherol. The news came up this month on pharmacological research on the use of delta tocotrienol in recurrent ovarian cancer. Now, ovarian cancer is the 5th largest killer of cancer in women, and the 5-year survival rate is a mere 50%. And in this study, they use Avastin. And Avastin in Europe is used 8 years ago, approved 2011, and in the US it only approved just last year for ovarian cancer. The study is on the survival outcome. And in this, they measure progression-free survival as well as overall survival. And in those just on Avastin, the standard of care is 3 months and the overall survival 6. And in essence, when they add delta tocotrienol and alternative therapy in addition to Avastin, they have extended the survival of women by double. And in this from 3 to 7 months approximately, and from 6 on the overall survival to 11 months. So I think that this is a remarkable thing to say the least on this study. And the study is done at the Vejle, V-E-J-L-E, spelled, Vejle Hospital in University of Southern Denmark with Professor Anders Jacobsen. And thank you for having me on. Thank you, the audience, for listening. Hopefully one of these days we'll meet in person. Good night and have a wonderful day.
That's great. Thank you so much, Dr. Berrie, for sharing such wonderful knowledge with us. It was really a pleasure to have you here with us. All this information is also available on our website at www.eannatto.com. All the research, clinical studies are also available to go through over there. If anyone has any questions or are looking for any specific research, they can always contact us directly via email. We are more than happy to answer their questions. Also, if anyone wants to buy Dr. Berrie's books, they're also available through our website. Wellness Extract is currently doing a clinical study with oncologist Dr. Sachin Gupta from Max Hospital in Mohali. If there are any other doctors who are interested in any kind of clinical study, they can also get in touch through our website with us. Thank you once again. It was really a pleasure having every one of you here. Have a wonderful day.